Hello, I'm going to do heating of the atmosphere for the grade 10 geography. You remember that we have the earth and the atmosphere, which are not the same. So now I would like to know from you guys, how does the earth get heated up as compared to how the atmosphere gets heated up? Because the two are not the same. So now when we look at the atmosphere, it is a gaseous layer that surrounds the earth, whereas the earth is a solid mass that we have as a globe. So now, when we look at how the atmosphere versus how the earth gets heated up, the first point of departure there is the sun. And we have got processes of heating up the atmosphere that we are going to learn today. So now, as the sun radiates out its rays towards the earth, we'll be having the first process that is called insolation. If you look at the word insolation, it comes from the three words incoming, solar, and radiation. You break it up into three: in, so, and lation. So now the first in means the incoming, so means solar, and the shin means radiation. So now that is where we get the energy of the sun from. So now this is the first term that will tell us about heating of the sun. When the sun rays comes from the sun directly to the earth, it comes through insolation. But it is not all of the sun rays that will heat up the earth, or maybe the atmosphere. So now some of this insolation, we'll find that some of it will go back to the space through the process called reflection. It will be reflected back to the space. So now reflection is a term which means that it will be redirected back into space. And another portion of the energy, or maybe the sun rays, will be scattered through the various molecules in the atmosphere. So now scattering, there we mean that it will be reflected back in different directions. So now the clouds are one of an example that will make our sun rays to scatter. But it is not all this that will be reflected back, or maybe that will be kicked back into space. We have a portion of the energy, the sun's energy, that will be absorbed through the process called absorption. If we can realize what I was saying through the lesson. So now we have got a lot of terms because we refer to processes which end up with the word shin because we relate it to the process. I spoke about insolation. I spoke about reflection. Now we have got scattering. And besides scattering, we have absorption. Our cloud molecules will be absorbing some of the sun rays. And besides this absorption, we'll be having some of this energy being radiated back into space. Now, the atmosphere is not heated directly by the sun rays. So now it will be heated through the scattered sun rays, or maybe the scattered energy. So now they will be the ones responsible for heating up the atmosphere. When the sun rays comes through the atmosphere to the sun, it comes through a process called conduction. So now in conduction, we have got the transfer of heat from one object to the next. Remember, as we do these processes related to the heating of the atmosphere, you must now and time and again remember about, or maybe recall, the tasks that we are going to have. In the last exercises that we had, some of you had a problem when it came to definition of terms. So now it is very important that as we do this vocabulary, each one of you should write the direct meaning. And again, we have got another process of heating called convection. So now it is not the 100% of the insolation that will reach the Earth's surface. And now when we look at the Earth's surface, it is not being heated equally. There are certain places that will be heated more than the others. So now we have got factors that will make the temperature not to be the same at different places. So now the first factor that I would like to talk about is latitude. In latitude, we refer to the imaginary line that we have across the globe running from east to west. So now the position of that particular location we're talking about in relation to the equator will tell us how the difference in heating occurs. Places next to the equator heats up more quicker and maybe are being hotter than places far away from the equator. Right, another factor that we have there is altitude. In altitude, we refer to the height above sea level, and it is indicated by the contour lines. So now, the places, we know that we have the notion maybe in the past that would say to us, the higher you go, the colder it becomes. But when we look at the various layers of the atmosphere, we know that in certain layers, as you go up, the warmer it becomes. But now we know that we have a normal decrease of 1 degree Celsius for every 100 meters that one goes up. So now when you go up, or maybe places that are in a higher altitude will have colder temperatures than places that are down there. Another factor, we have got the ocean currents. So now we have warm ocean currents and the cold ocean currents. Warm ocean currents have a tendency of bringing in warm temperatures into the land. Therefore, we find that places that are on the coast will be affected by the ocean currents running next to them. And colder ocean currents will bring in cold temperatures. Another factor that we have is distance from the ocean. So now we look at the location in place in relation to the distance from the ocean. Oceans heat up quicker than land, and they even lose heat quicker than land. Coastal locations are cooler in summer and they are warmer in winter. I have a diagram here for us to look at how insolation is reflected back, how insolation is scattered or maybe absorbed by the wind, by the clouds, as well as other particles in the atmosphere. So now you really need to take those terms and match them up with the processes that we are having of heating. And we have an exercise that we are going to do today. And the exercise will start by asking you to come up with the definitions. Remember, when we say you define, the word define means that you must give a concise and clear meaning to that particular word. You attach a meaning and define that particular word. And again, you may be requested to name the processes that will lead to different, or maybe the factors that will lead to different temperatures at different places. So now when you name, you just state, or maybe you just mention. And sometimes you may be requested to differentiate the processes. What is the difference maybe between conduction and convection? So now you'll tell us the difference between how heating is taking place. And remember, in all the examination papers, we have got the discussion type where you'll have to examine, where you'll have to give your point of argument and present both sides in order for you to reach a better conclusion of the said statement. So now, I would like us maybe to try to discuss how incoming solar radiation affect, or maybe is being affected by the atmosphere. There you'll be coming up with those processes that we have dealt with, the processes that will divert, or maybe that will not make, or maybe make it impossible for the 100% of the insolation to reach the surface of the earth. So now it is then that you will come up, or maybe you will discuss how each of them, as well as the amount that they have, how they will affect the ultimate insolation reaching the earth's surface. Right, we have talked about reflection, we have talked about scattering. Now there is a certain percentage of the insolation that will be absorbed by the earth. And the portion that is being absorbed by the earth will be reflected into the atmosphere through the long wave radiation. That is how the atmosphere is being heated up. It is not like the earth. The earth is absorbing the insolation, but the atmosphere does not absorb the insolation. It is being heated up by the long wave radiation. And now, in summary, I would like to urge you to go and look into the atmosphere and look at the plains, look at the clouds, and see, or maybe attach to them the processes, because they will not be the same. So the plants will be reflecting back, clouds will be absorbing as well as reflecting, and the earth will be absorbing. You will have to attach meaning of those processes to reality. You now look at the plants, you look at the clouds, you look at the earth's surface. You now identify which one will absorb, which one will reflect. And then you'll be taking all that we have taught into practice. Thank you.